Attention is the ability to focus on specific stimuli. This can be seen when you study for an exam or when you notice a dog running across the street. Every time we concentrate on specific stimuli, we suppress our focus of other things. For example, when you're studying, you are focusing on the material you need to know for the test, and you are suppressing the information of the library environment around you. People could walk behind you and you wouldn't notice because you are only attending to your study material. This is called selective attention. Selective attention is the process of focusing on a particular stimulus in our environment while simultaneously ignoring other information. Selective attention can be seen in our example of the dog also. When you notice the dog running across the street, you didn't acknowledge the color of the house you were passing at the time. While selectively attending to the dog, you suppressed your attention for the color of the house. Now, let's say you were on a walk during this time and attending to other stimuli in your environment, when this dog ran across the street and caught your attention. This would be called attentional capture. The dog shifted your focus from your phone or the path in front of you. Not only did the dog capture your attention, but he also captured the gaze of your eye. This takes us into overt and covert attention. Overt attention is seen in our dog example and is the process of shifting attention from one place to another by moving the eyes. On the other hand, covert attention does not alter eye movements, but instead shifts one's mental focus. But when does this happen? Let's take a football game for example. When the quarterback is preparing to throw the football, his gaze may indicate that he is about to throw the ball one way, but his covert attention indicates otherwise, and he may throw the ball toward a different player. The quarterback has to use his periphery to scan the surroundings while maintaining his central vision in a direction that leads the other team astray. But wait, how does this mental shift in focus affect our speed of processing after a cue? Well, Michael Posner had the same question and thus created the spatial cueing task. He wanted to investigate the effects of covert attention in response to different pre-cueing conditions. In this task, subjects were told to fixate on a central cross in between two boxes. While fixating on the cross, a cue was presented. After the cue disappeared, a stimulus was presented in one of the boxes, and the subject had to respond to the stimulus depending on which box it was in. Posner used two different cues, one that was presented above the cross in the central visual field, and another presented around the boxes in the peripheral visual field. The cues either indicated where the stimulus would be or would not be. In order to make sure the subject was staying fixated on the central cross, subjects' eye movements were tracked by electrodes near the eyes. Posner found that if the cue matched the location of the stimulus, the reaction time of the subject was smaller. With this experiment, Posner proved that attentional shifts in a target area can precede eye movements. But how does this happen? What brain regions are playing a part in this process? Well, there are two factors that determine how people shift their attention: top-down and bottom-up attention. Bottom-up attention is based primarily on physical characteristics and is indicated by attentional capture. In bottom-up attention, the ventral parietal cortex coordinates with the superior colliculi and subcortical arousal systems. The ventral parietal cortex is activated when presented with salient stimuli. The superior colliculi receives visual signals from the retina and helps with the orientation of the eyes. The subcortical arousal systems are different interacting brain structures that coordinate arousal and alertness levels. Now, top-down attention is based on cognitive factors such as the observer's knowledge about scenes and past experiences with the stimuli. This type of attention is associated with visual scanning. When people are presented with a scene, they normally look at the objects that are out of place first. Three brain regions coordinate together to create top-down attention: the anterior parietal cortex, frontal eye fields, and the dorsal parietal cortex. The anterior parietal cortex is a primary area for selective attention. The frontal eye fields play an important role in the control of saccadic eye movements for the purpose of visual field perception and awareness. The dorsal parietal plays an important role in the direction of attention in space. Now let's think about all of this for a second. The functioning and interacting of these brain areas allows you to focus on an assignment, physically shift your focus toward a dog, and even mentally shift your focus when throwing a football. Attention is a primary step for further cognitive functioning, but that's information for another video. Thanks for watching.